The theory of everything has been found. Hello, my name is Harry Sarantopoulos and I have found the theory of everything. And what this theory tells us is that everything in the universe is made from just two objects. Everything from particles to galaxies to you and me. Some of the things we're going to see is how a physical structure at a fundamental level leads to everything in the universe, how fundamental forces like gravity are created, and how particles are made, and why the universe has an accelerated expansion. We are going to see why we can believe in this theory and what makes this theory much more superior to all other theories. And what we will also see is how paradoxes are resolved, like light. Is it a particle or a wave? It's both, and I'm going to tell you how. So why haven't we been able to find this theory until now? We've been trying to explain the universe in a mathematical way. This, of course, allows us to quantify the universe, which is an important part in understanding it. But mathematics alone won't give us a complete understanding of the universe. We need a physical description of how it works. We first need to describe the universe without mathematics, and then lay the mathematics onto that description. A physical description is absolutely necessary. For example, we can measure gravity, but nobody can describe the mechanism for gravity. General relativity tells us that mass warps space. But what exactly does that mean? This is why it's important to have a theory that gives us a description of a physical dynamic. My theory can describe the universe in that way. Now, there's been attempts in the past to do this. The Lesage theory of gravitation and the ether theories of the 19th century. These theories failed for several reasons. The Lesage theory failed primarily due to the increase in heat the inelastic collisions would create. The ether theories failed due to the drag it would exert on objects. My theory overcomes these limitations. So the universe is made from just two objects. But what are these two objects? Well, the first one is physical lines that have mass. These lines are millions of light years in length. However, they have a diameter that is less than the radius of an electron. So the diameter of an individual line is incredibly small, but its length is incredibly long. The lines are flexible, so they are not rigid. They can bend in any direction. They are fully elastic and are indestructible. These lines make up the entire universe, so you can imagine how many lines there are. The lines do have mass, so they are a physical object. However, regardless of their mass, these lines do not in themselves create gravity. I will explain what creates gravity later. The next object that makes up the universe is the smallest particle in the universe, smaller than an electron, and I call this particle the quantum particle. This particle also has mass, and all quantum particles have the same mass. Its diameter is the same as the diameter of a line, so it's incredibly small. It's the smallest object in the universe and the most numerous object in the universe. Its energy is kinetic, its collisions are perfectly elastic, and it's also indestructible. The energy of the universe is the elastic kinetic ability of the quantum particle. So from just these two objects, everything in the universe is formed, from electrons to galaxies. So why should we believe that these two objects exist? We can believe that they exist because of the ability of this theory to explain a wide range of phenomena, from how electrons are created to how gravity works, to why the universe has an accelerating expansion. General relativity can't do that. Neither can quantum mechanics, the Standard Model, or string theory. So how do two objects create everything in the universe? Well, first, they create a field. So our universe is a finite physical field existing in pre-existing space. So it's an object in space that has a size. There is space in the field and outside of the field. The combination of quantum particles and lines form a three-dimensional field structure. Lines are orientated in 3 dimensions. Parallel lines are separated by lines orientated in a 90-degree direction to them. This forms a 3-dimensional grid pattern, a Euclidean space. However, the lines are not in contact with each other. What keeps them separated is the quantum particle bouncing between them. The lines not in contact with each other is an important part to the structure of the field because this allows the quantum particle to move around the field freely. This prevents a build-up of quantum particles in any location, allowing for quantum particles to be evenly spaced in the field. Therefore, the field is a homogeneous system. Apart from the quantum particles, there is unoccupied space between the lines and outside of the field. The field lines prevent the quantum particles from escaping. This conserves the energy in the field. The universe, therefore, is flat with zero curvature. It is a finite object with an edge. However, this structure allows for an accelerating expansion. Therefore, it is growing in size. The consequence of this is that the energy in the universe is weakening. I will discuss this more in cosmology. The flexibility of the field structure and the quantized energy of the quantum particle is a fundamental state. So let's look at some fundamental principles of this theory. Quantum particles bouncing between two field lines will impart their kinetic energy to the lines. The closer the field lines are to each other, the greater the energy. This is because it takes less time for the quantum particles to travel between the lines. Therefore, the further apart they are, the weaker the energy is. So this mechanism allows force to be inverse to distance. Quantum particles act as a repulsive force, pushing the lines apart. However, when we add more lines, a counterforce is created on either side, preventing lines from moving. This equalizes energy and creates a potential energy. So even though the quantum particles are still bouncing between the lines, the fact that the lines are not moving creates a zero or neutral energy. This exists throughout the field. So we have a field that is homogeneous, equal in energy throughout the field, a balanced energy, but having the potential for that energy to increase or decrease. So quantum particles bouncing between field lines is in principle similar to an ideal gas. Quantum particles are all the same size with the same mass. They are constantly moving and moving in random directions. Their speeds vary but average out to a constant pressure on the field lines. At this fundamental level, no other forces apply, electric, magnetic or gravitational. Only a kinetic force exists. All collisions are perfectly elastic. No conversion of kinetic energy into any other form. Temperature is not a factor at this level. We will see how heat is generated later. Now, the absolute pressure exerted on a given mass is inversely proportional to the volume it occupies. This is a statement describing an ideal gas, a physical mechanism at a macro level. This statement is also true for the quantiparticle and field lines. The pressure on the field lines increases as the distance between them decreases, and the pressure decreases as the distance increases. So we see a similar action at a fundamental level and at the macro level. We have seen that the field has a three-dimensional structure with lines separated by quantiparticles. The flexibility of this structure allows the field to be put into certain dynamics. Field lines can be put into a wave motion. The field structure is flexible due to the space between lines, the flexibility of the lines, and a finite number of quantiparticles between lines. A disturbance in a localized part of the field will create a longitudinal wave that will radiate outwards like a stone thrown into a pond creates a wave. A line can also be put into a transverse wave, in which the wave is at 90 degrees to the direction of travel. So we see that this mechanism allows for the propagation of waves along the field. The elasticity of the field lines and the large distance between quantiparticles allows for a contraction in a localized area of the field. The mechanism allows the lines to be distorted inward. This compression of the field in turn creates a localized inverse to distance force, where the lines are closer together at the center and further apart, moving away from the center. If the distance between the lines is made shorter, then the pressure increases and decreases if lines are wider. As I said before, the field lines create a counterforce. This allows for a conservation of energy, an absolute requirement for any theory of the universe. However, the field is a finite object. Outside of the field, no counterforce exists. Therefore, the repulsive force of the quantiparticle on the last lines will expand the field. The last lines will move first, followed by consecutive lines. This will lead to an accelerated expansion. One of the great mysteries of the universe is the accelerating expansion of the universe. Physicists have introduced a repulsive energy, dark energy. They can't explain its nature, and they misunderstand the way the accelerating expansion is happening. First, they believe that the accelerating expansion is happening equally in all parts of the universe. And as it expands, more dark energy comes from somewhere and maintains its density. The reality is that the accelerating expansion is greater in the outer part of the universe than it is near the center. And in the outer part, because the field lines are wider apart, the energy is weaker. So we see how important it is to have a theory that describes a physical dynamic. We call the electron an elementary or fundamental particle. However, electrons are composed of quantiparticles. Quantiparticles are indivisible and are the base particle for the formation of larger particles like electrons. I spoke earlier about how the elasticity of the field allows for a localized contraction of the field. So a particle like an electron is created when the field in a localized area is universally pushed together towards a central point. Quantiparticles in that area are pushed together to form a central mass, and the field lines are pushed onto that mass. So now the field lines encapsulate the mass of quantiparticles, and the field is now distorted inward. The lines closest to the mass are the most distorted, and moving away from the center, the lines become less distorted. This creates an inward directional distortion, radiating away from the center in diminishing strength because the distance between the field lines is closer near the center than further away. So now force is inverse to distance. This creates a negative field and becomes the field of the particle. As the field is three-dimensional, the force is divided by the square of the distance. However, by compressing the quantum particle into a central mass, a large repulsive force is generated in the encapsulated particles. This force would push the lines back to an undistorted state, and they would no longer encapsulate the quantum particles as a central mass. What prevents this from happening and holds particles together is a funneling effect. When the field is compressed to form the particle by encapsulating quantum particles into a mass, a radius is formed. This radius creates a second distortion by projecting into the first distortion. The inward direction of the field lines forms a funnel, directing the quantum particles onto the radius. Therefore, a quantum particle entering this funnel would be deflected off the angled lines and directed to the center, where it would collide with the radius. So a net directional force is created, because more energy is directed towards a smaller area. Returning quantum particles move back to a larger area. The energy colliding with the radius is equal to the energy pushing the radius out. The energy hitting the radius is equal from all sides, therefore it is a balanced particle. We know that particles like electrons are stable. This theory tells us that the amount of energy in a particle pushing the lines back must be equaled by the same amount of energy hitting the radius. This tells us that the universe only provides enough energy to maintain particles with a certain size and mass. However, we know that much larger, unstable particles that decay quickly can be created. Particles like the Higgs, the W and Z bosons. Physicists believe that they are force-carrying particles, like the weak nuclear force. However, they do not carry force. So what are they for? The formation of a stable particle like the electron requires more energy than is needed for just that particle. As the field is compressed, quantum particles in the area are pushed into a central mass. Therefore, there are no quantum particles in the immediate area outside of that mass. This would lead to the central mass pushing back out, and therefore you would have no particle. What provides energy to prevent this is the formation of large but short-lived particles surrounding the central mass, like the W and Z boson. As they decay, they release quantum particles, therefore providing the required energy to prevent the unraveling of the central mass. These large particles decay quickly because the energy inside them is too great for the energy outside to hold them together. So these large particles are created to provide energy to help form stable particles. They do nothing else. We will see later how particles are attracted and repelled, and how we don't need the nuclear force to hold the nucleus together. So an electron is a mass of quantum particles encapsulated by the field lines. It would seem that if it moved in any direction, the field lines would get entangled, but this doesn't happen. So even though this mass is surrounded by field lines, it is subjacent to the field. Therefore, this mass is in between field lines. This prevents the entanglement of the lines as the object is moving. The field itself is at rest. It can only be dragged a very short distance. So the lines only move along with the mass for a very short distance. As the object begins to move through the field, lines are detaching from the object that were attached to it and are constantly being replaced by oncoming field lines. So lines are disengaging and engaging from the object as it moves through the field. This process happens at the speed of light. So this process cannot be outrun by the speed of the object. One of the major problems with Lesage and ether theories is that they inevitably create resistance as an object moves through the field. What these theories lack is an ability to overcome resistance. Resistance is an unavoidable consequence of any theory that speaks of the universe as a physical field. However, understanding the plasticity of particles gives us an understanding of how resistance can be overcome and how an object stays in constant motion. Particles like electrons are not rigid objects. An electron is a collection of small quantiparticles encapsulated by field lines. The quantiparticles are not held together as a rigid mass. Individual quantiparticles can move against one another, allowing the formation to be shaped by an external force. This allows an object a high degree of plasticity, so any movement in any direction will change the shape of the object. As an object accelerates, it will be hit by more quantiparticles from the direction it's moving in. This force begins to change the shape of the object. It contracts and narrows the front of the object and also elongates the object. If we look at an object with no field lines, we see that the narrowed front will miss most of the oncoming quantiparticles. This reduces resistance. Furthermore, quantiparticles will hit the object on an angle, reducing the impact energy. So an object in motion has undergone a shape change. It's narrow at the front and elongated. The majority of the mass has migrated to the rear of the object. This projects the back of the object more into the field. So behind the object, the field lines have been pushed much closer together. The closer the lines are, the more energy, and therefore a push force is created behind the object. So that object is pushed forward. So under acceleration, an object's shape will change. When it stops accelerating, the amount of energy hitting the front in the form of the quantiparticle is now constant. This keeps the object in a rigid state, so its mass is no longer shifting and its shape stays constant. Therefore, the push force from the back is constant. So what we see is that for a constant motion, the field in front of an object in the direction of travel must have reduced energy. This would be a negative field, and behind the object is a positive field. As long as the relationship between negative and positive energy stays the same, an object will move at a constant speed. The conventional understanding of an object in constant motion is that it doesn't need a force to keep it in motion. This type of thinking is a cop-out in physics, and it happens all the time. Rather than trying to find a theory that can explain something, we just accept what has been said in the past. In the case of momentum, we can't explain why an object has more energy with a higher velocity. Where does that energy come from? So as velocity increases, the energy of an object increases. However, the mass of an object is invariant. It doesn't increase or decrease, it stays the same. What does change is the field around an object. The extra energy is created in the field around the object by accelerating the object. We have seen how an object has more energy due to its mass extending into the field and creating a push force. So what we are beginning to see is the equivalence of mass and energy. When an object increases or decreases its speed, energy is taken or given back to the field. Therefore, momentum is always conserved. So this theory gives us a deeper understanding of mass and energy. Let's say there is a rocket accelerating an object in space. The object will encounter more quantum particles from the direction it's moving into. So there is more force from that direction. This force is the feeling of acceleration. So the force of acceleration is a very real physical force. So why do physicists tell us that it's not a real force? Well, that comes from Einstein's observation that a free-falling observer in a closed box would not be able to detect the force of gravity. Therefore, this would be an equivalent feeling to floating in space. And as you accelerate in free fall, it must not be a real force. But what physicists don't understand is how a gravitational field can create an accelerating force, while an observer in a box in free fall feels like they're floating. Later in the section Gravity, I will tell you exactly how that happens. The universe only creates negative particles. A particle is created when the field in a localized area is compressed to form a central mass. These particles are the electron, the photon, and the neutrino. A negative particle is a particle that has the field lines pulled inward towards a central point. At that center, a radius is formed. So energy in the form of the quantum particle is directed inwards. Now, of course, we know the proton is positive, but the proton is constructed from a number of negative particles. Later in the section How to Build a Proton, I will explain how this happens. At this point, I will render a simplistic description of a positive particle. A positive particle has an extended radius, much greater than a negative particle. This extended radius does not overcome the negative field, so it's a positive particle in a negative field. The field cannot be bowed out. If hypothetically that was to happen, the quantum particles could not be contained as a central mass. So the proton is a negative particle in relation to the undistorted field. But because of its extended radius, it's positive to the negative electron. What this tells us is that particles, electrons, protons, and everything else can only exist in an inward distortion of the field. Given a sufficient amount of distance between two objects, the field is not distorted. This is a very important thing to understand because it gives us a deep insight into special relativity, an insight Einstein never had. And we will delve into that in the section Time, Velocity, Distance, and Our Existence. Opposite charges attract each other. Protons have positive charge and electrons have negative charge. That's the explanation we get. So in other words, they really don't know how it happens. Virtual photons are exchanged between protons and electrons. That's another attempt in explaining it. But where did they come from? My theory tells us exactly how particles attract or repel each other. And it also tells us that virtual photons are real and are created as a byproduct of this process. What I'm going to describe is the basic principle for how particles attract and repel, and later I will talk about virtual photons. The proton and electron will be attracted to each other because a reverse geometry exists in their fields. So the field of the negative electron will fit into the field of the positive proton. The proton's positive field is projected outwards. This will match the outer negative field of the electron. All particles have an equal amount of force surrounding them, so they are balanced from all sides. If there is a difference in energy on one side, then the particle is unbalanced and a directional force is created. As the two particles come within each other's influence, their fields accommodate to each other's field. However, it's not a perfect fit. Differences in each field means that they do not accommodate exactly. Large gaps between field lines occur. Therefore, the quantiparticle must travel longer between field lines. This weakens the energy between the two particles. However, on their opposite sides, the energy, which is a force, stays the same, and that force is greater than the lower force between the two particles. Therefore, the two particles are pushed towards each other. So it's an unbalanced force that pushes particles together. Two protons will repel each other because as they approach each other, the outward projected field lines will be pushed closer together. So it takes less time for the quantiparticles to travel between the lines. This creates a greater amount of energy between them and pushes the two protons away. So a mechanism exists to push particles together or repel them. So what is a photon? Well, as described earlier, particles are created when the field is compressed in a localized area. This process only forms negative particles. The photon is produced in the same way as the electron, but it's much smaller than the electron. So the photon is a negative particle that has a field and it also has mass. The photon mass is very small but non-zero. So why do they say it's a massless particle? The argument for that is that it's always moving at the speed of light and never at rest, therefore never gaining relativistic mass, because you can't accelerate an object to the speed of light. My theory tells us the physical reason why you can't accelerate to the speed of light. When an object accelerates, the front of the object is narrowing and contracting, reducing resistance. However, it will eventually encounter so much resistance that it will match its push force from behind and be prevented from getting to the speed of light. So how can a photon have mass and still travel at the speed of light? The photon's energy, and therefore its speed, comes from a slingshot effect by the field lines. As I described earlier, an object moving through the field requires a push force for constant motion. However, there is a different but similar dynamic for the photon. As a photon pushes into the field, it pushes the lines closer together. This creates a lot of energy ahead of it, and it's this energy that then propels the photon, bouncing it between lines. The mass of the photon at the apex creates the maximum amount of force that can be created in the field, the square of the speed of light. As the photon pushes into the field, it begins to slow. At the apex, the photon has been stopped by the field. The amount of times it's not moving would be very short but not insignificant. The small size of the photon in relation to the distance between field lines means that it's not at maximum resistance until it's at the apex, so it doesn't gain relativistic mass. A photon moving between parallel lines could be regarded as a massless particle because during this period they are not pushing field lines together, so they're not replicating their mass in the field. When a photon pushes into the field, its mass is registered by the field. The dynamic that propels the photon suggests that the photon does not move at the speed of light, but speed averages to the speed of light. So it will necessarily at times be moving faster than light. This is not a problem because it's going faster than light in the period when the field does not register it. Light, is it a particle or wave? It's both. This debate has been going on for more than 200 years, and because we haven't had a theory to explain it, science has branched off into quantum weirdness. Well, my theory explains it, and there's nothing weird about it. So we just saw how the photon is propelled by the field. The photon hits the lines at an angle which is less than 90 degrees. so it's propelled forward in a wave motion along the parallel structure of the field lines. As the photon hits one set of lines, it creates an area behind it that has less quantaparticles. Therefore, parallel lines below are pushed up. So the oscillation is in the y direction as it's moving in the x direction. The wavelength of the photon depends on the angle it hits the field lines. A shallow angle will produce a longer wavelength, and an acute angle will produce a shorter wavelength. Regardless of the wavelength, the speed of light is constant. That's because every time the photon is propelled by the field lines, it receives a new amount, but the same amount of energy. This is why the speed of light is constant regardless of the velocity of the emission source. However, shorter wavelengths result in the photon taking longer to traverse a distance due to the greater oscillation motion. So photons with different wavelengths will arrive at different times. Therefore, gamma photons, which have the shortest wavelength, will take longer to arrive. Let me restate that the speed of light averages to the same for all photons, no matter what the wavelength. The difference is in the distance a photon must travel due to different wavelengths. Now, physicists have found that gamma photons, which are high-energy photons emitted from distant galaxies, have arrived on Earth later than lower-energy photons. My theory easily explains why. Now, every time the photon pushes the field lines together and creates the energy that propels it, it also creates an opposite and equal amount of energy that continues in the direction the photon was originally traveling in. This creates a longitudinal wave in that direction in the field. This energy is not a photon particle, which are quantaparticles encapsulated by the field that are pulled into a central point. It's just quantaparticles pushing against the lines, creating a wave of energy that moves through the field. This energy has the momentum of a photon. These parcels of energy can be regarded as virtual photons, energy created in the field. The virtual photon begins moving at the speed of light, and because it's not a particle like an electron, it cannot gain energy around it. Unlike the photon, the virtual photon does not vary in speed, so it will always be moving at the speed of light, and it will have the energy of the photon but not its mass. So the wave component of light is the field lines, and the particle is the photon. Therefore, light is a particle and wave. One of the experiments that helped develop quantum mechanics was the double slit experiment. This experiment has confused physicists and led them to describe the universe as a space of probabilities. Describing the universe that way tells us nothing about how it works. If you're not familiar with the double slit experiment, there's a lot of YouTube videos about it, and I recommend you see them before continuing. So now I'm going to tell you exactly what is happening with the double slit experiment. We have seen with my theory that photons can create virtual photons that have the energy of a real photon. The double slit experiment presents physicists with two mysteries. The first one is, when you have two slits and you shoot one photon only through one slit, you get an interference pattern as though another photon went through the other slit and created that interference pattern. How do they explain this? They say that the wave does not have a physical nature, but the particle in the double slit experiment only exists as a wave of possible locations that encompasses all possible paths, and only when the particle is detected that a location is decided. But what is really happening? Remember that the virtual photon has the energy of a real photon. What passes through one slit is the photon itself, and through the other slit is the virtual photon. Therefore, you get an interference pattern. The second mystery is when you place a detector next to the slits to see which slit the particle actually passes through, it behaves as a particle, not a wave. How do they explain that? They say that once a detection is made, a location and the path it took to get there is decided. So what is really happening? Well, first, let's go back to what a virtual photon is. It's a loose connection of quantiparticles with the energy of a photon, so it's not a bound particle. This means that if it collides with something, it will be registered as a real photon. However, this collision will disperse the quantiparticles, so the virtual photon does not exist anymore. So the detector next to the slit is detecting real photons and virtual photons as real photons, and at the same time dispersing the virtual photons, so you get a particle and no interference pattern. Quantum mechanics can't give us a description of how things physically work. They say it's meaningless to define a particle's properties before the wave function collapses. This means that we can never understand what goes on at a fundamental level. So this is why we need a theory that describes a physical reality, not something we can never make sense of. Gravity. Newton says it's a force. Einstein says it's not a force, but mass distorting space-time. A massive object generates a gravitational field by warping the geometry of the surrounding space-time. Well, he's right about saying an object warps the geometry surrounding it, but he's wrong about it not being a force. It really is a force. Gravity is an inward distortion of the field lines, just like the inward distortion around a negative particle. Therefore, it's a negative field. So the field lines are pulled towards a central point. The field lines are more distorted and closer together as you approach that central point. The closer the lines, the greater the energy. Moving away from the central point, the lines become less distorted, so the energy or the force weakens over distance. As the field is three-dimensional, the force in the distorted field is inverse to the square of the distance. The field lines do have mass, but it's the central mass of an object that distorts the field lines to create gravity, not the lines themselves. So Einstein was right about a massive object warping the geometry surrounding it, because the geometry of the field lines has changed. The distorted shape of the field has an immediate effect on any object entering the field. I explained earlier how matter has a plasticity. So matter entering a gravity field is affected by the field and begins to conform to the distorted field. Therefore, an object entering a gravity field will be affected by the field instantaneously. This allows action at a distance. The distorted field affects the object, but the object also affects the field. So when an object enters the field, it changes the entire field. However, that change can only be transmitted at the speed of light. An object in a gravity field will in part conform to the field and will also distort the field. So an object in free fall will have the lower part of it elongated because the field lines are stretched towards the central mass. Above the object itself is creating a second distortion in the field. The object pushes the field lines above it closer together. The closer the field lines are to each other, the more energy is created, and that energy or force pushes the object down. So it's this energy that the object creates above it that is the force of gravity. So any mass in a gravity field distorts the field and generates gravity. Now, below the object,
the field is negative, and above the object itself is creating a positive force. Let's say you're holding onto a bar above your head, so your legs are dangling off the ground. You feel like you're being pulled and stretched. This is because the lines below you are stretched. So at the same time, you are being pushed and pulled towards the ground. As an object is falling, the lower part of the object is moving into an increasing negative field. Above the object, the positive energy is also increasing, because the field is becoming more distorted and therefore the object generates more energy. This increases the speed of the object, therefore the object is accelerating. However, the ratio of change for the negative energy below and the positive energy above is constant. This is why if you were falling in a box, you would feel like you were floating in space, and you don't feel acceleration. So it's important that we understand that it's a constant ratio of change of negative energy below and positive energy above that gives an equivalence to floating in space. Now all mass falls at the same rate. This is because different size mass will distort the field above them and replicate force that is equivalent to that specific mass. Therefore, everything falls at the same rate. How do objects stay in orbit? First, let's look at a general shape of an object in freefall. The lower part is elongated to fit the negative field, and the upper part pushes up into the field. In orbit, the shape of an object is different due to the forces applied to it from different directions. From direction B is the force of gravity pushing it down. However, for an object to fall, we need a positive field above and a negative field below. So because the object is in a static state, not falling, it's not moving into an increasingly negative field. The negative field below is not as negative as it would be if it was falling. The reason for this is due to two things happening at the same time. Above the object, the positive field is pulling the negative field below it up. And below the object, the energy in the V shape is weaker than the energy below that. So it will push up to fill that more empty space. This creates a more neutral gravitational force. Now, what causes an object to move forward in orbit is its elongated shape that gives it its push force from direction A. The main support to staying in orbit comes from direction D. This gives the object an angled shape. This more broader surface means more quantaparticles are colliding with it, and this prevents it from falling. This angled shape at point E is projecting more into the gravity field than the rest of the object. This means that it's pushing the field lines there closer together, creating more of a gravitational push force directed to the center of mass. As this force is ahead of the object, it creates a pivot point and causes the object to constantly change direction. So just like an object in constant motion, if the forces on it stay the same, then it will remain in constant motion. So an object in orbit will stay in orbit because the forces on it are constant. Even though the object is changing direction, it's not accelerating. This is because the field has been put into a curved geometry and the object has conformed to that geometry.
Well, that's the end of part 1. In part 2, we'll see what is really inside a proton, and it's not quarks. It's just electrons, and I'll tell you how that is possible. I'll explain what time is. We will see what my theory tells us about special and general relativity, and a few things Einstein got wrong, and some things he didn't even know about. I'll tell you about the connection model, and how that tells us how gravity, the electric force, and the magnetic force are really connected. And the reality of our existence. Don't worry, it's just science. So what makes more sense to you? My theory that gives us a physical reason for how things really happen, or theories like quantum mechanics that says the universe is comprised of pure possibility, that a particle only exists as a wave of possible locations that ultimately encompasses all possible paths. So tell me what makes more sense to you in the comments below. And if you like this theory, click on the like button and share this video.